Let's look at a enhancement on the binary search algorithm. Back to the PowerPoint slide. When we have a lecture with the PowerPoint slide says binary search algorithm is only applicable to an array that is sorted ascendingly, meaning the smallest come first, then gradually increase its value until the last one is the largest. At that time, we already mentioned that that was not entirely accurate. In fact, the proper statement is that the binary search algorithm, as we implement it, is only applicable to ascending arrays. However, the idea of binary search, the idea of looking at the middle value and choose the half that will contain or may contain the desired value. This binary search algorithm, this divide and conquer strategy, is applicable to all sorted arrays. So we can also apply the same thing to a descending array. We just need to change the way that we identify which half we need to discard. So let's say we have a descending array, the first one is the largest, then it gradually decrease until the last one is the smallest. How should we apply our search? The idea is still same. You get a middle value. I'm not sure which one is the middle value. Let's just say this is a 310 is the middle value. The middle value, and you want to split this into half. The first half, everything is bigger than middle value. So if middle value is greater than the desired value, then everything in the first half will be greater than the desired value. So we can safely discard the whole part, only focus on the second half. But if the middle value is less than the desired value, then we know that everything on and after middle value will be less than the desired value. So this part can be discarded. Then we can recalculate the last and recalculate the middle, and the process goes on and on just like before. So let's make a new class called binary search descending demo. And let's copy the binary search. I don't need the package. Actually, I don't need the class name either. So all I need to do is copy the body. Did I miss something? Oh, I believe. All right. And let's apply proper indentation. Okay. And also let's copy the new array, which is actually just this array reordered. And now, remember we said that the whole idea of binary search is still same. We will still have the while loop. We will still compare first and last, whether they are overlapping or not. We will also still calculating the middle value. This printout is still the same. The only thing happening here, the only change is when you compare middle value to the desired value, which part do you choose? So here, if middle value greater than the desired value, which means the whole first part are greater than the value, then you will need to use the upper half, right? So here we are going to move this. If you are going to discard the first half, then you will move the first to the one after middle. That's when you will move this over. And let me move the comment too. And that's it. That's everything you need to do in order to rewrite this ascending code to adjust to adjust to descending code. So let's run and let's search for 234. And you can see that it's the same printout, the similar printout. The first one, this is probably the desired middle. And the first one get a middle, and the middle is greater than the desired value 234. So the first half is discarded. We get a second part, and then we get this 207 as the middle value, middle equals 14. Then because 207 is less than 234, so the first half is kept all the way until we found the proper one. All right. So, but as you can see, this part is relatively easy. So you can also add a Boolean expression here to make it more flexible. The Boolean expression can be called like ascending. So if Boolean expression is true, then you can utilize the previous logic that array middle less than value, then you will do this middle plus first equals to middle plus 1. Or if the Boolean ascending is false, which means you want to you want to search in a descending array, then you will use another logic. So these are the things that you can enhance, or you don't even need to use a Boolean expression. You can compare the first few elements. If you can find a pattern, if it's descending, then you use one logic. If it's ascending, you use another logic. So all these are potential enhancements to this binary search algorithm.